Hello viewers, my name is BC Emmanuel. Welcome to my channel BC Online Math and Physics. In this video we are going to continue from where we stopped in physics. If you have been following us, we have talked about derived quantities and their units. But today we are still on the topic, don't forget that. We are still on this topic, units and measurements. Units and measurements. Don't forget that. Still on this topic, and we have discussed fundamental quantities and their unit, derived quantities and their unit. Now we want to discuss dimension of physical quantities. Dimension of physical quantities. Very important. Dimension of physical quantities. In dimension, there are three basic quantities that we are going to use. Three basic fundamental quantities. We have mass, don't forget that. We have length. We have time. Don't forget that. Mass, the unit of mass is kilogram, right? The unit of length is what? Meter. The unit of time is what? Seconds. Let us say x. Yes. Now, wherever you see kilogram, you represent it with what? Capital M, which is mass, right? Now, wherever you see meter, it's represented by what? L. Wherever you see seconds, it's represented by what? Capital T. So, dimension of physical quantities make use of M, L, T. So, this is what represents a dimension. If you are talking about dimension, mass, length, and time, they are the ingredients of dimensions. Now, I want to tell you something about units. Do you know in units we have two types of units? Types of units, we have types of units. We have one, system international units. Let me just explain this. System international units. Two, standard international units. The standard international units. Let me just short it like this. Both of them are called SI units. Don't forget that. SI units. That's why they say, what is the SI unit of mass? Is what? Kilogram. But these two units, the one we are using now, currently, is System International Unit. So this one is the one science is using now. Because this one is just an old format. But the one we are using now is System International Unit. Now, in System International Unit, the unit that we make use is what? Kilogram, meter, and what? Seconds. Kilogram, meter, and seconds. These are the units they are using in System International Units currently. That's why if you have something like 0.5 gram, so they can tell you in physics under motion a ball of 0.5 gram. So you see now, so that gram is telling you that the mass of the ball is what? Is 0.5. Now, you cannot use that gram to calculate any calculation given to you, but you are going to use kilogram. You are going to convert that gram to kilogram. So that is why this is System International Units is an approved unit in physics. That even though your calculation is in gram or in centimeter, you have to convert them to this. This is what physics recognizes. Now, this standard international unit is normal one, gram. centimeter and also seconds. So they both agree in seconds. But before you can calculate any calculation in gram, in centimeter, in seconds. So, but now we are working based on system international units. We are now dealing with kilogram, meter, or what seconds. So if you have something like 2 gram, you are eligible to convert this 2 gram. You can't use this in your calculation. Don't use it in your calculation. You have to convert it to what? Kilogram. By what? Dividing by what? 1000. So you convert it to what? Kilogram. By dividing it by what? 1000. So you cannot use this gram. Whenever your calculation, your given values is in gram, you are asked to convert to kilogram. Because we are working based on system international unit. If you are given in centimeter, you convert to meter. If you are given in seconds, it's still seconds. But if you are given in minutes, you convert to seconds. If you are given in hour, you convert to seconds. So that's how it goes. Now, that's all about this aspect. I've explained this. Now let's go back to dimension now. Let's go back to our dimension. Let's go back to our dimension. Now, number one, let's talk about speed. Can we find the dimension for speed? Yes, we can do it. Now, speed. Before we know the dimension for speed, we have to know the formula. What is the formula for speed? The formula for speed is what? Distance over what? Over time. In derived quantities, right? Yes. Now, can we know the units for speed? Yes, we can know it. Distance is in meter. Over time is in what? Seconds. So that shows us that the unit of speed is what? Meter per seconds. That's the unit for speed. Meter per what? Seconds. Now, since we have gotten the unit for speed, now the dimension will be very easy. Look at the dimension here. Since the unit of speed is meter per seconds, now the dimension coming. Wherever you see meter, I've told you, wherever you see meter, you represent it with what? L. Wherever you see seconds, T, right? Wherever you see kilogram, M, capital M. Now, this meter is talking about length here, right? L. This S is seconds, talking about time, T. So this minus 1, just put it here. So this becomes the dimension of speed. So the dimension of speed is LT raised to the power of minus 1. So this is the dimension of speed. Now, let's talk about velocity. Are you aware that velocity and speed has the same units but different formula? Velocity is displacement over time. Change in displacement over time. And don't forget that displacement is in meter, right? Yes. Displacement is in meter. Then time is in what? Seconds. Have you seen now? Now, you can rewrite this as what? Meter per seconds. Yes. Meter per what? We have explained how to rewrite it in our last video. So you can write M over X as meter what? Per seconds, like this format. Now, let's now talk about dimension of velocity now. Meter per seconds. Meter per seconds, Abi. Now, whenever you see M, small m here, represents what? L. N. Now, S is what? T, right? T. Now, minus 1 remains minus 1. This is the dimension of what? Of velocity. Now, let me open your mind how they ask this type of question. I'm going to stop here for today. Then in the next video we continue from density. Now, you can see that this and this is the same thing, right? LT raised to the power minus 1, LT raised to the power of what? Minus 1. JAMB or WAEC will test you that which of the following has the same dimension as speed. Just look at this. They will tell you which of the following has the same dimension as speed. This is what they will just tell you, ask you. Which of the following has the same dimension as speed? They will say A, density. They will say B, acceleration. They will say C, velocity. They will say D, let me just put force. They will just scatter it like this. So if you don't know dimension of physical quantities, you can't answer this question. It's not by magic. You just pick wrong one. But have you realized that this and this are what? They are the same, right? Now, which of the following has the same dimension as speed? You see now, the dimension of speed is this. Dimension of velocity is this. They have the same dimension. The answer is what? C. That's how they ask the question. Very simple. So, in our next video, we talk about density and gather process. We don't rush. We do it line by line so that you understand. So, if you enjoy this video, please like, comment, share, and also subscribe for more videos so that when I post the next video, you'll be aware, you'll be notified. So, but if you don't subscribe, you won't know that I've posted any video. Please subscribe for more video. Thank you. God bless you.